Somewhere beneath the ground your grandparents walked on, there is a room that has been keeping food alive for 200 years. No electricity, no refrigerant, no compressor humming in the night, just earth, stone, and an understanding of physics so precise that a carrot placed inside in October will still be crisp in June. Your great-great-grandmother knew this, so did her mother, and the Vikings knew it 1,000 years before either of them. Then one industry sold your family a refrigerator, and the room beneath the ground was sealed up, forgotten, and eventually paved over. This is the story of what was buried, not just in the ground, but in memory. And by the end, you will understand why the most reliable food storage system ever built can be constructed for less than $2,000, needs zero electricity to run, and will outlast every appliance in your kitchen by at least 2 centuries. You are watching Lost Build Archives. If you have not subscribed, do it now. Because what this channel covers is the knowledge the construction and appliance industries would prefer you never found. 40,000 years ago, before agriculture, before cities, before the concept of ownership had fully formed, human beings were already solving the problem of food storage underground. Early Paleolithic people stored mammoth carcasses in frozen ponds. They packed fish into fermentation pits. They used the ground itself as a refrigerator because they understood something fundamental about the earth. Below a certain depth, it stops caring what season it is. The physics have not changed. The planet absorbs solar heat slowly and releases it slowly. Surface temperatures swing wildly, from -30 in a Minnesota winter to 110 in a Texas summer, but go down 4 to 6 feet into undisturbed earth, and that chaos disappears. The temperature stabilizes at the regional mean annual temperature year-round within a few degrees. In most of the continental United States, that is 50 to 55 degrees Fahrenheit. With proper ventilation design pulling cooler night air down and warm air out, you can drop that to 34 to 40 degrees, which is exactly what your refrigerator tries to achieve using a compressor, refrigerant, and about 800 kilowatt hours of electricity per year. The Earth does it for free. It has always done it for free. The Vikings called their version a jordkjeller, which translates roughly as earth cellar. The construction was straightforward and permanent. They chose a north-facing hillside, where the sun's heat had the least impact on the surrounding soil. They dug back into the slope, typically 6 to 8 feet deep and 12 to 15 feet long. They lined the walls with stone, dry laid without mortar, which allowed for slight air circulation while providing thermal mass. The roof was timber and sod, 2 feet of compacted earth on top, sometimes more. The door faced north. There was a simple ventilation shaft at the rear upper corner, and a lower intake vent near the door. The result was a chamber that held between 35 and 42 degrees Fahrenheit, regardless of whether it was August or February. Viking families stored an entire harvest in these cellars. Cabbages, turnips, carrots, beets, dried fish, smoked meats, and fermented dairy. They did not preserve food so much as park it, still alive, in a controlled environment, to be retrieved as needed across 8 or 9 months of winter and early spring. A family with a well-stocked jordkjeller was a family that did not die. A family without one was a family that gambled every autumn on whether their food would last. Those same families built their cellars to last forever, and in many cases, they did. Now let us cross the Atlantic, to a small town on the northeastern tip of Newfoundland, on the Bonavista Peninsula. The town is called Elliston, and it holds a title that sounds impossible until you understand the history. Elliston, Newfoundland is the root cellar capital of the world. A team of researchers from Memorial University catalogued 135 root cellars within the boundaries of this single small community. The earliest documented cellars date to 1839, nearly 200 years ago. More than half of those cellars are over 100 years old, and half of all the cellars they found are still in active use today. Not as museums, not as tourist attractions, as root cellars working food storage. Marilyn Coles-Haley, who chairs the Tourism Elliston Committee, put it plainly. She said, "Everyone had a cod fishing boat, a subsistence garden where they grew root vegetables, and a root cellar to store them during the long winter. That was the complete system. The boat fed them fresh protein in season. The garden fed them carbohydrates. The root cellar stored that garden's output across the months when nothing grew. These three elements together constituted total food independence. No grocery store, no supply chain, no dependency. And those root cellars, built with stone and earth by fishermen who were not architects, are still standing, still functioning, still maintaining temperature. Nearly 2 centuries after the men who built them died. In 2021, when the pandemic had already stretched supply chains thin and grocery shelves in Newfoundland went bare because supply boats could not get across, something happened in that province. People started asking about root cellars again. The Food Security Network of Newfoundland and Labrador launched a program called Root Cellars Rock, specifically designed to revive the knowledge before it died, with the last generation that had used it. Local families who still maintained their cellars became teachers. Old construction techniques, passed down informally, suddenly had an audience desperate to learn. Food security is something that people are latching onto, as one organizer put it. In the beginning of the pandemic, grocery shelves were getting bare because food could not be brought over. The root cellar was not a relic, it was a solution. But Elliston and the Vikings are just 2 data points on a line that stretches across every serious civilization in recorded history. Because independently, on separate continents, without any communication, human beings kept arriving at the same answer to the same problem. In Persia, around 400 BC, engineers built the yakhchal, which translates as ice pit. These were conical structures rising as much as 18 meters above ground, with a subterranean chamber beneath them that could hold up to 5,000 cubic meters of material. The above-ground cone functioned as a solar chimney, pulling heat upward and out through the top, while cold air sank into the underground chamber. The walls were built from sarouj, a mortar made of sand, clay, egg whites, lime, goat hair, and ash that was essentially impervious to heat transfer. In the middle of a Persian summer, the underground space stayed cold enough to preserve food and even store ice that had been harvested in winter. The poorest families in the city could access it. This was public infrastructure built on physics, available to everyone. In Korea, families buried large earthenware vessels called onggi in the ground each winter. The onggi were made of clay with a porous microstructure that allowed air to pass through but not water, creating an environment where fermentation could proceed slowly and safely. Kimchi buried in an onggi pot underground did not freeze. It did not spoil. It fermented at exactly the right pace to be ready when needed, months later. The practice is at least 6,000 years old. The physics are identical to a root cellar. Use the Earth's thermal mass to maintain a stable, cold temperature. In ancient China, written records from around 1000 BC document the systematic harvest and underground storage of ice and snow. By the time of the Tang Dynasty, ice was being packed into copper boxes and used to refrigerate fruit. The wealthy had ice cellars. The principle spread. Every food culture that had access to Earth figured out that Earth was the most reliable refrigerator ever built, which makes what happened in the 20th century so extraordinary. Because all of that knowledge, accumulated across 40,000 years on every inhabited continent, was dismantled in a single generation. Here is exactly how it happened. In 1925, only 1 in 3 American homes had any form of mechanical refrigeration. By 1942, that number had risen to roughly half. After World War II, refrigerator manufacturing exploded. The returning veterans were buying houses in suburbs, and those suburbs were designed without cellars. The new ranch-style home that became the American standard after 1945 had a slab foundation. No basement, no cellar, no underground storage. This was not accidental. Suburban development was driven by a coalition of interests. Federal mortgage policy, automobile manufacturers who needed suburbs to sell cars, and the appliance industry, which needed the suburban kitchen to sell refrigerators. The slab foundation made the appliance mandatory. If you had no basement, you had no cellar. If you had no cellar, you needed a refrigerator. And the refrigerator was not a one-time purchase. It broke down, it needed service. It required electricity, which meant a monthly bill. When it wore out, you bought another one. The modern refrigerator is one of the few appliances that is specifically designed to need replacement. The average American refrigerator lasts between 10 and 15 years. A good one might stretch to 20. Then it goes to the landfill, full of refrigerant that has to be specially handled, and you spend another $1,500 to $3,000 on its replacement. Do that over 50 years, and you have spent somewhere between $7,500 and $15,000 on refrigerators alone, plus the electricity cost, plus the service calls. Meanwhile, the root cellars of Elliston were completing their second century of operation at zero additional cost. The appliance industry did not suppress the root cellar because it failed. It suppressed it by making it architecturally impossible and then filling the gap with a product that required ongoing payment. There is no conspiracy meeting in a boardroom where executives decided to eliminate root cellars. It is subtler than that. It is the natural outcome of designing a housing stock that makes self-sufficiency impossible and dependency mandatory. When every new home built after 1950 had a slab foundation and a refrigerator hookup already wired in, the root cellar did not need to be banned. It simply ceased to be an option. One generation grew up without them. The generation after had never heard of them. The knowledge that had sustained human civilization for 40,000 years evaporated in 40 years. That is what a successful erasure looks like. Not a ban, an absence. And now we need to talk about what that absence costs. The average American household wastes $1,500 worth of food every year. A significant portion of that waste happens because the refrigerator is the wrong tool for certain foods. Potatoes should not be refrigerated. Neither should onions, garlic, winter squash, beets, or carrots. Refrigerator temperatures below 40 degrees damage these foods, converting starches to sugars, accelerating cell breakdown, causing premature rot. But if you have no root cellar, the refrigerator is your only option. So you refrigerate things that should not be refrigerated, they deteriorate faster than they should, and you throw them away. In a root cellar maintained between 32 and 40 degrees with 85 to 95% humidity, the same vegetables thrive. Potatoes last 6 to 9 months. Carrots, properly packed in damp sand, keep for 7 to 9 months. Beets hold for 5 to 6 months. Cabbage, wrapped individually and stored on shelves, stays fresh for 4 months. Winter squash lasts 4 to 5 months. Apples, separated by variety and checked weekly, keep for 4 to 7 months depending on cultivar. A properly stocked root cellar in October is a grocery store that operates through June. And then there is the question of what happens when the grid fails. On February 13th, 2021, an Arctic air mass pushed south into Texas. The power grid failed. Within 72 hours, 4 million households had no electricity. The outage lasted in some areas for more than a week. Temperatures inside homes dropped below freezing. Pipes burst, people died, and across Texas, millions of families opened their refrigerators and freezers to find that everything inside had spoiled. The food loss per household was estimated at hundreds of dollars in many cases, with insurance companies authorizing up to $500 per claim for grocery losses alone. Multiply that across 4 million households and you begin to understand the scale. Every root cellar in Texas was unaffected. The ground did not lose power. The stone walls did not fail. The temperature inside every earth-sheltered storage chamber in that state held steady at whatever the regional mean temperature happened to be, completely indifferent to the catastrophe happening above. This is the difference between infrastructure and equipment. Equipment fails. Infrastructure endures. And now, for the first time in 70 years, people are building root cellars again. Not as a hobby, not as a nostalgia project, as a deliberate choice to exit a system that charges them monthly for a service the earth provides for free. One Pennsylvania homesteading couple documented their root cellar build publicly online. They spent $2,300 on materials, mostly concrete block, gravel drainage, and a solid wood door. They hired no contractors. The build took 3 weekends. 2 years later, they reported storing over 800 pounds of produce across a single growing season, including 300 pounds of potatoes, 150 pounds of carrots, 60 heads of cabbage, and an assortment of beets, turnips, and apples. Their grocery bill dropped by more than 40% between November and April. $2,300, one time, spread across the lifespan of a structure that will function for at least 200 years, is $11.50 per year. Their chest freezer, by comparison, cost $700, uses approximately 400 kilowatt hours of electricity annually, and will need replacement in approximately 12 years. The math is not close. Now let us go inside the cellar. Let us understand, in specific physical terms, exactly how it works and why. Picture a hillside. The ground slopes away at roughly a 30-degree angle facing north. The soil is loam over clay, typical of most of the eastern United States. You mark out a rectangle 14 feet long and 9 feet wide on the slope. You begin to dig, not down from the top, but back into the hill. At 4 feet of depth below the surface, you have already crossed the threshold where seasonal temperature variation is damped by more than 90%. At 6 feet, you're in a zone where the temperature is essentially locked to the regional mean. In Pennsylvania, that is 52 degrees Fahrenheit. In North Carolina, 58. In Minnesota, 45. In Oregon's Willamette Valley, 52. The excavation goes back 12 feet into the hillside. You are now surrounded on 3 sides and above by earth that has been sitting at a stable temperature, undisturbed, for as long as anyone can remember. The walls at this depth are not passively cool. They are actively pulling heat out of the space. Any heat that enters from produce respiring, from a person entering to retrieve food, from a warm day in early fall, is absorbed by the surrounding earth mass and dissipated. Now you line the walls. Not for structural reasons alone, but for airflow management. Stone laid dry without mortar allows a small amount of air to move through the wall matrix. This prevents moisture from accumulating and eliminates condensation on the wall face. The floor stays as earth or is covered with gravel, which drains any moisture that accumulates and maintains the high humidity that root vegetables require. The roof is the critical element. You lay timber across the span, then pour 2 feet of compacted earth on top. That earth has a thermal mass of approximately 30 British thermal units per square foot per degree, which means it resists temperature change with enormous inertia. A heat wave that lasts 3 days will barely register inside. The earth roof has absorbed the heat, averaged it, and by the time it begins to conduct inward, the weather has already changed. Now the ventilation. This is where most amateur root cellar builders make their single critical mistake. A root cellar without proper ventilation becomes damp, stagnant, and eventually anaerobic. Produce stored in stagnant air develops mold and off flavors regardless of temperature. The Viking design solved this with 2 ports. The intake is positioned low, near the door, facing north, open to the coolest available air. The exhaust is positioned high, at the rear of the cellar, at the highest point of the interior. Cool, dense outside air enters at the bottom, absorbs moisture and heat from the produce, and rises as it warms, exiting through the high exhaust. The flow is continuous and requires no fan, no motor, no power. It is convection, and it has been working reliably in this application since the Neolithic period. The door matters enormously. A single solid door leaks heat. The best traditional designs use 2 doors, an outer and an inner with an airlock space between them, essentially a small vestibule. When you open the outer door, the inner door stays closed, preventing a rush of warm outside air from entering the storage space. You step into the vestibule, you let the outer door close, then you open the inner door. Inside the cellar, it is dark and cool and quiet. The smell is clean and damp like good forest soil after rain. The stone walls glisten faintly with condensation that never quite accumulates. The air is still. Along the walls, wooden shelves hold crates of apples, wrapped individually in newspaper, stacked 2 layers deep. Below them, bins of carrots buried in moist sand, roots down. On the floor, sacks of potatoes sit in loose burlap, away from the apples because apples release ethylene gas that causes potatoes to sprout. In the far corner, a row of ceramic crocks holds pickled beets, the brine still clear after 4 months. Hanging from the timber ceiling by their roots, 6 cabbages, their outer leaves intact, still showing the faint waxy bloom. That means they are alive and not merely preserved. This is not a primitive arrangement. This is a precision system. Every element has a reason, every placement has a logic. The people who designed this did not do so by accident. They did it by observation and refinement across hundreds of generations, until every mistake had been made and corrected, and the system that remained was optimal. Temperature, 38 degrees Fahrenheit. Humidity, 91%. Outside, it is January. There are 2 feet of snow on the roof. The temperature at the nearest weather station is 11 degrees above zero. And in here, not one thing has changed. The apples in the corner were placed there in early October. They will be retrieved through March. The carrots were packed in September. Some of them will still be firm in late May. The potatoes in the corner were harvested in August, cured in a warm shed for 2 weeks to harden their skins, and moved in here in mid-October. The last of them will be eaten in April. The family that built this cellar has not bought a vegetable from a grocery store since October. They will not need to until June. That is the system, not a product. A system. One that costs nothing to run, nothing to maintain, and nothing to replace. Now let us talk about what it costs to build one. The most common modern approach uses concrete block for the walls, which provides thermal mass and structural stability without requiring the stone masonry skills of previous centuries. A standard single-room root cellar, approximately 8 feet by 12 feet by 7 feet tall, requires roughly 350 concrete blocks at approximately $2 each. That is $700. Gravel for drainage, $100. A solid wood door, either built or purchased used, $100 to $300. Ventilation pipe, $50. Miscellaneous fasteners and lumber for shelving, $150. Total materials, approximately $1,200 on the low end, $2,000 if you buy premium materials or hire help for the excavation. The excavation itself is the one cost that varies most widely. If you have a hillside on your property, a rented mini excavator for a weekend is about $400. If you are digging into flat ground and building an earth-covered mound structure instead, costs are similar. If you hire a contractor for excavation only, add another $500 to $2,000. All in, a well-built root cellar costs between $1,500 and $4,000, depending on site and materials. It requires no ongoing expense, no electricity, no service contracts, no replacement cycles. Compare that to the alternative. A mid-range chest freezer costs $600 to $900. It uses between 400 and 500 kilowatt hours of electricity per year. At the current national average electricity rate of 15 cents per kilowatt hour, that is $60 to $75 per year in electricity. It will need replacement in 10 to 15 years. Over a 50-year horizon, accounting for 2 to 3 replacement cycles and ongoing electricity costs, a chest freezer costs between $5,000 and $9,000. The root cellar costs nothing after construction. The freezer costs money every single month forever, and fails completely when the power goes out. There is something the industry will not tell you about that chest freezer. When the power fails, and with climate events increasingly disrupting the grid across the United States, the question is no longer if but when. Every dollar of food inside it is at risk the moment the compressor stops. The average American has between $300 and $700 worth of food in their freezer at any given time. One extended outage destroys all of it. The root cellar does not care about outages. It does not care about hurricanes, ice storms, grid failures, or rolling blackouts. Its energy source is geothermal. Its mechanism is convection. Its structure is stone and earth. These things do not stop working, and the revival is not waiting for permission. Across the United States, Canada, and the United Kingdom, a quiet movement is building root cellars at a rate not seen since before World War II. They are appearing in backyards in rural Tennessee, in the sides of hills in Vermont, under garage floors in Montana. Built by people who watched their freezer contents rot during a 3-day outage, or who did the math on their grocery bill and food waste, or who simply asked the question, what did people do before refrigerators? The answer was always the same. They built a room in the ground. Some of these modern builders are documenting their work in extraordinary detail. A homesteader in western Pennsylvania filmed his entire root cellar build online, from initial excavation through the first harvest storage. The cellar is 12 feet by 10 feet, dug into a north-facing slope, stone walls, dry laid, earthen floor with gravel drainage, 2-door airlock entry. Total materials cost was $2,100. He has stored produce there for 3 growing seasons. He reports that his vegetable waste over those 3 seasons dropped by roughly 70% compared to his previous years, without a cellar. He also reported that his root cellar is the single most satisfying project he has ever completed. The reason he gave is this: it keeps working when everything else stops. The technical requirements are not exotic. You need a site where you can achieve at least 4 feet of earth cover on the roof, ideally 6. You need drainage. The water table in your area needs to be at least 2 feet below your planned floor depth. And this is the critical due diligence step that most amateur builders skip. A root cellar that floods is not a root cellar, it is a swimming pool. Get a soil probe and check your drainage before you break ground. You need ventilation. The 2-port convection system is simple to install and requires no power. You need a door that seals well without being airtight, because some air exchange is necessary. You do not need electricity. You do not need a thermostat. You do not need any mechanical system whatsoever. The one modern addition that significantly improves performance is a small, inexpensive thermometer and hygrometer, which allows you to monitor temperature and humidity from outside the cellar. You can purchase a wireless sensor for $20 to $30 that sends readings to a phone. This lets you open or close vents to fine-tune conditions without having to physically enter and check. The Vikings did not have this. They managed just fine without it. But if you have $25 and a smartphone, you are building a smarter jordkjeller than any Norwegian fisherman ever had access to. There are regional variations worth understanding. In the deep south, where mean annual ground temperatures run from 60 to 65 degrees, a standard root cellar will not get cold enough for most storage. But the same physics that cool a northern cellar can be used to build an insulated cool room inside an existing basement packed with thermal mass and equipped with a small cooling coil connected to a ground loop. This is called a cool room, or cold pantry, and it maintains temperatures in the required range year-round at a fraction of the cost of a conventional refrigerator. In the desert southwest, the Persian yakhchal principle applies. Use a deep chamber with a solar chimney above it to pull hot air out and keep the underground space dramatically cooler than ambient. This works in Albuquerque and Tucson and Phoenix, though the storage durations are shorter than in cooler climates. In the Pacific Northwest, the mild climate means ground temperatures stay in an ideal range year-round, and a root cellar there is almost embarrassingly easy to build and maintain. The challenge in that region is not cold, it is moisture management. The point is that the physics adapt to every climate. Every human civilization that faced a winter ever solved this problem using a version of the same tool. The specific design changes. The principle does not. Here is the question that should be sitting with you right now. If this works so well, if it is this simple, if it is this much cheaper, if it is this reliable, why does nobody teach it anymore? The answer is that nobody teaches it because nobody profits from it. A root cellar, once built, generates zero revenue for any corporation. It does not require refrigerant, it does not generate an electricity bill, it does not need a service contract or a replacement cycle. It is a permanent infrastructure improvement that makes a family more self-sufficient and less dependent on external supply chains. That is not a product, that is an exit. When families in Elliston built their root cellars 200 years ago, they were not making a statement. They were feeding their children through the winter. But in the context of the current economy, where every aspect of food production and storage has been industrialized and turned into a subscription, building a root cellar is an act of quiet defiance. You are telling the appliance industry that you do not need their product. You are telling the electric utility that you will not pay them to keep your carrots cold. You are telling the grocery store that you will not be there every week because what you grew in your own ground will carry you through to spring. This is what the people of Elliston understood, and what Newfoundland rediscovered in 2021. Food security is not complicated. It is not expensive. It does not require technology. It requires knowledge. And the knowledge, once lost, takes a crisis to recover. The world right now is providing the crisis. The average American household spends approximately $9,000 per year on food. A household with a working root cellar and a modest garden can reduce that by 30 to 50%. That's not a small number. Over 10 years, that is between $27,000 and $45,000. Money that, instead of going to grocery stores and utility companies, stays in your pocket. The people of the Viking Age understood something that has taken modern civilization 1,000 years to forget, and is only now being remembered. They understood that food security is infrastructure. That infrastructure should be permanent. That permanent things are built of earth and stone and timber, not compressors and refrigerant and plastic. They built rooms in the ground. Those rooms still work. Every farmstead in America had a root cellar before 1950. Your great-grandparents used one. Their grandparents built the first one on their property. The knowledge was unbroken for millennia. The refrigerator interrupted that chain in a single generation, not because it was better, but because it could be sold and resold and built and serviced. The root cellar cannot be built. That is the only reason it disappeared. And that is the only reason it is coming back. The families who are building root cellars right now are not survivalists or eccentrics. They are people who did arithmetic. They are people who experienced one grid failure too many and decided that their food supply should not depend on infrastructure they do not control. They are people who found the photographs of their great-grandparents' farmstead and noticed the low wooden door set into the hillside behind the barn and asked what that was. It was the most reliable food storage ever built. It was free to operate. And it was theirs. You can build one. The engineering is simple. The materials are available at any building supply store. The physics have been verified by 2,000 years of continuous use across every continent on Earth. Ground temperature data for your specific county is available from the United States Geological Survey. Your local extension office has soil drainage maps. The rest is stone, earth, a door, and 2 ventilation pipes. The root cellar the Vikings built was not exotic technology. It was applied observation. They noticed that food placed underground stayed cold. They refined the design until it worked optimally. They passed it down. Every civilization that faced a winter arrived at the same place. Now it is your turn. The room is still there, in the hillside behind where your barn would be, or in the north side of your yard, or beneath your garage floor. The earth has not changed. The physics have not changed. The ground temperature in your county is the same as it was when the Norse farmers dug their first jordkjeller into the side of a Norwegian hill 1,000 years ago. It is waiting. The only thing that was buried more completely than the root cellar was the knowledge of how to build one. And now you have that knowledge back. What you do with it is entirely up to you. The root cellar solved food. But 3 days without water is a different kind of emergency. There is a filter that costs $50 to build. It removes 99% of bacteria from raw, untreated water. It runs on gravity, no electricity, no cartridges, no service contract. It lasts 25 years with 0 replacement parts. 2 million families in 70 countries depend on it right now. And the industry selling you $1,000 systems with 6-month cartridge subscriptions has made absolutely sure you have never heard its name. That is the next video. Click it now.